Today's topic is a combinational logic and the K-map, and here as you see here four variable K-map have been displayed here, and in given here we'll be using zeros and don't care symbols to mention here to your left side when we use x denotions to mark any square in place of minterms. It has been denoted as a don't care value, and the grouping can be done with neighboring elements or the values or either zeros or one. So to your right you can see the grouping is done as the center four ones have been grouped here, and parallelly the four corners ones have been grouped together, because as we it is been considered as the variables will fold together to create a sequel circuit kind of thing. So here from left one and right one has been grouped together to form three separate groups, and this came up, it feels a little difficult using Boolean algebra laws, rules and theorems to simplify logic, and KEMA provides a systematic method for simplifying Boolean expression, and if properly used it will produce simplest SOP or POS expression possible, known as minimum expression. So SOP is sum of product and POS is product of the sums. So it is similar to the truth table. Instead of being organized the input and output into the column and row, the K-map is an array of cells in which each cell represents a binary value of the input variable, and the cells are arranged in a way so that simplification of a given expression is simply matter of properly grouping the cells. So K-map can be used for expressing 2, 3, 4 and 5 variables, and here 3 and 4 variables will be discussed to illustrate the principle. So as we see here there are 8 cells shown here. So here we use 3 variable K-map, and here as we discussed in earlier videos, A, B and C are the 3 variables. We can group it as A, B, C or A, B and C. So here C value is given as 0 and 1, hence we are taking only two row columns, and we have 4 rows here denoting the variant logical equivalent of logical binary equivalent of A and B variables. So A, B is given as 0, 0, 0, 1 and 1, 1, 1, 0, and denoting here here we consider 0 value as A dash, that is the complement value, A dash, B dash and C dash, and A, B, and when the C value is 1 we have only the A dash, B dash, C, and in the second row we have A dash, B, C dash, and in the second column of the second row we have A dash, B, C, and similarly in the third row first column we have A, B, since we have A and B values are logical ones, and here C value is 0, so we denote C as C dash, and in second column A, B, C, since all the variables values or 1 here, and 1, 0 is A, B dash and C dash, and here A, B dash A, B dash, C. So likewise when we map the 4 variable K-map, we have similar concept of mapping the variables in the square mapping. So here we have A, B's values listed in the row value, and C, D values given in the column value. So we have to say take the similar values, similar range of values when mapping the rows and columns. The n rows and n columns should be same here, and here how do we cell adjacency is the concept given here. So adjacent cell is denoted here. So for the column 1 and 2, the second column's adjacent cell is to the left, it is 0, 0 for 0, 1. So for 1, 1 column the adjacent cell will be 0, 1. For 1, 0 column the adjacent cell will be 0, 1, 1. So similarly the first row and the second row are adjacent to each other, and similarly as you see here yeah, 0 0, I mean first row and first column is adjacent to first row last column. Okay, so this is the adjacent here. So this is a simple example of um, grouping the ones example. So we shall take grouping of ones for performing sum of products and grouping of zeros for performing per product of the sums. So here we have different examples taken and the grouping is done here. So here in first example ABC, the ones values have been denoted in the minterm values given, and the grouping is then done as you see here with the adjacent things. So similarly for this for 4 variable also we have given the adjacent. Okay, thank you.